So today we are going to cover Chapter 1, Section 5A, so the first part of Section 5. And today we are going to learn about complex numbers. Now there are two facts right here at the top. You need to memorize these. Now I know this one right here, it's kind of hard to tell, but this is an I squared. So I squared is equivalent to -1, and the square root of -1 is equal to I. So you need to memorize these two facts here. When we're going to be adding and subtracting or multiplying and dividing, what we're going to do is treat I as a variable. So basically we're going to be combining like terms when we add and subtract. However, when we multiply, and this should be an exponent here, this should be an I squared. Whenever your answer includes an I squared, we're going to replace I squared with -1, and then we'll simplify. The standard form, when we have a complex number in it, is always A plus BI, where A represents the real part of the answer, and the B times I is representing the imaginary part of the number. We will not be graphing imaginary numbers. You'll do that later on. But just understand that whenever we have a negative number under a square root, it's going to produce an imaginary number. Up until this point, every problem you've already been doing has been with the real number system. Now, just to show you something simpler before I ask you to write that in standard form. So when we break down a square root that has a negative number under it, what I like to do is factor it first, and my first factor will be a -1, and then the other factor will be the positive of that number. And then if at this point you realize 4 is a perfect square, you can just square root it. And I just told you to memorize that the square root of -1 is I. So when I square root the 4, I get 2. When I square root the -1, I get I. So the answer to the square root of -4 is 2I. So back to this one that was written here, I don't do anything with the real. I could break down my -25, and I can break it into a -1 times 25. And then square root of 25 is 5. Square root of -1 is I. So then this would simplify into 2 plus 5I. And that's in the standard form. It's got the real part and then the imaginary. Now, when you're breaking down these square roots, you don't have to show me the factor tree of the -1 times the number. You're going to get to the point where you're going to be able to do it mentally. It's not going to matter. Pretty good on this slide? Let's try some examples. We're going to be adding, subtracting, and multiplying. So again, whenever you're adding, all you're going to be doing is combining like terms. So I'm going to add my reals together. So 4 plus 1, and I get 5. And then I'm going to add my imaginaries. 7I plus -6I is just I. So really treat it like a variable when you're adding and subtracting, and just combine like terms. Same thing on the next one. You're going to add your reals. 1 plus 3 is 4. And then 2I plus -2I is 0. So my answer is just 4. The next one, be careful with the subtraction signs. I'm subtracting the whole quantity. So you either need to think of this as being a -1 that you're going to distribute, and then distribute it to both. So let's just rewrite distributing all these subtraction signs. So this will become 3I, and then when I distribute that, I get +2 minus 3I minus 2 minus 5I. All I did was distribute all of the subtraction signs. Now I'm going to go back and add my like terms, or add my reals and add my imaginaries. So I have a +2 real and a -2 real. So I don't have any real left because 2 minus 2 is 0. And now I'm going to go back and get my imaginaries. 3 minus 3 is 0. And then minus 5 is just -5I. because these ended up canceling, and you were just left with negative 5i. So you're just combining like terms when you add and subtract. Same thing on number 4. I'm going to distribute the subtraction sign first. So let me just rewrite my problem. So it becomes 3. So I'm going to just rewrite the problem and distribute the subtraction sign. And now I'm going to go back and look for my like terms. So I'm going to add my reals first. So I have a 3, a 4, and a negative 7. And that's going to give me 0. And then I'm going to go back and get my imaginaries. 2 minus 1i is 1i minus 1i, and my answer is 0. The next one, I'm just doing distributive property. Again, just treat it as if it were an x, a variable. So I would distribute the 4 to the negative 2. I get negative 8. 4 to the 3i, and I get 12i. And I'm done. Can't combine them. They're not like terms. Number 6, I'm just going to FOIL it. Again, treat it like a variable. Now, what's going to be different on number 6 is when I FOIL this, anytime I get an I squared in my answer, I need to replace that I squared with what it equals, which is 1. I'm going to replace with negative 1. So I squared equals negative 1. So I'm going to replace I squared with what it equals, and I know that I squared equals negative 1. So let's FOIL it. Combine our like terms, and then anytime we see an I squared, we're going to take it out and put a negative 1 in its spot. So I'm going to FOIL. First is 2 times 4 is 8. Outside gives me plus 6i. Inside gives me negative 4i. And last gives me negative 3i squared. So now I can replace the I squared with negative 1. And I'm also going to combine my outer and my inner. So this will become 8 plus 2i. And then I'm going to replace I squared with negative 1. I need to multiply that. And I get 8 plus 2i plus 3. Because negative 3 times negative 1 is positive 3. And then I have 2 like terms, 2 reals that I can add. And my final answer is 11 plus 2i. Yes. Yes. All right, let's try number 7. Again, same thing. We're going to FOIL it. But whenever we see an I squared, we're going to replace it with negative 1. So I'm going to FOIL. 3 times 3 is 9. 3 times negative 2 is negative 6i. Inside gives me 6i. And last gives me 4i squared. Now, again, notice the middle here. These are going to cancel. I'm going to replace my I squared with negative 1. And then I'll multiply that, and it becomes positive 4. And then I add that, and my answer is 13. Number 8. Remember, this is a binomial squared. We need to write it 2 times. Do not just try to square the 3 and square the 2i. You'll miss out on the middle term. So remember, we write it twice and we FOIL it. Or you memorize the pattern for a binomial squared. Either way. So first is 9, outside 6i, inside 6i, last is 4i squared. Again, I'm going to add the middles now, and I'm going to replace the I squared with a negative 1. So 9 plus 12i plus 4 times negative 1. I'm going to multiply the 4 times the negative 1, and I get negative 4. And now I can add my reals, and my final answer here is 5 plus 12i. Going to do the same thing on number 9. I'm going to FOIL it. So outside gives me 6. First gives me 6. Outside gives me plus 6i. inside gives me negative 12i, and last gives me negative 12i squared. Again, I can add my middles and replace I squared with negative 1. So 6 minus, so positive 6 minus 12 is negative 6i, and then 12 times negative 1, I'm going to multiply that. I get positive 12, add my two reals, and my final answer here is 18 minus 6i. So again, adding and subtracting and multiplying, it's basically the same thing you've been doing, treated as a variable. The only trick here is when you end up with an I squared, after you multiply, replace it with a negative 1, and then simplify. The next one, these are examples of complex conjugates. So a complex conjugate is going to have the same numbers but opposite signs, just like when we had the radicals. So when you multiply by the conjugate, the I is going to disappear. So it's sort of like rationalizing when we rationalize with radicals. The shortcut, just remember, is whenever you're going to multiply something by its conjugate, you're just doing first and last, okay? Or just squaring the A, squaring the B, and then adding them. So let me show you what it means. I'm going to do it the long way, and then I'll show you the shortcut. So I'm going to multiply this by its conjugate. Its conjugate is going to be same numbers, but I'm going to change the sign in between. And now I'm going to FOIL it. I'm going to do it the long way, but then I'm going to show you the shortcut. So here I'm going to do first is 1 times 1. Outside gives me negative I. Inside gives me positive I. And last gives me negative I squared. Again, remember, I need to replace I squared with a negative 1, and I can also combine the middles. So remember, my outer and inner, they're going to cancel always. And then 1 minus, and then I'm replacing just the I squared. So just this got replaced with this. I still had the subtraction sign in there. And then this ended up becoming 1 plus 1, and it was 2. So again, shortcut, you can just do, the shortcut would have led you to just 1 minus I squared, and you could just square it and do first and last. So what you could do here is 1, you did the shortcut, minus, and then it was I squared, and then this turned into 1 plus 1, and then it was 2. But again, if it confuses you, just do the whole FOIL. So here, conjugate, flip the sign, FOIL it, 4 times 4, 16. Remember, outer and inner are going to cancel, so just do first and last. But I'll do the whole thing, plus 12i, minus 12i, minus 9i squared. This cancels. This becomes negative 9 times negative 1, and it becomes 16 plus 9, and you get 25. So again, you can just do the shortcut, just do first and last. All denominators must be rationalized, and the way that we'll rationalize is by multiplying by the complex conjugate. Pretty good on this slide? Yes. So when we're dividing with complex numbers, all denominators must be rationalized. In other words, we cannot leave an I in the bottom of a fraction, just like you can't leave a square root or a radical in the bottom of a fraction. So to rationalize, we're going to multiply by the complex conjugate. So let's practice that. So we've got our fractions here. We need to get rid of the I in the denominator. So I'm going to multiply by its conjugate, its complex conjugate. And for this one, it's going to be same numbers, but opposite sign. So the conjugate here is going to be 1 plus I. And remember, whatever you do to the denominator, we're going to do to the numerator. And again, shortcut for when you multiply something by its conjugate, just do first and last. So all I'm really doing here is 1 times 1 minus I squared. The top I need to distribute. I need to get rid of this I squared because remember, when we multiply by a conjugate, it's making that I disappear. So now what I can do here is turn the I squared into a -1. And then 1 minus -1 turns into 1 plus 1. So now I have 4 plus 4i over 2. And now I need to reduce this. I have to, whenever I simplify, I need to be able to divide the 2 into both numbers. So this will become a 2, and this is a 2i. So my final answer here is 2 plus 2i. So whenever you go to reduce this fraction, that denominator needs to be able to divide into both numbers. Let's try the next one. Again, I'm going to multiply by the conjugate. This time I have to FOIL the top. I have to do the whole FOIL process. So again, the conjugate, though, is 1 minus I, and whatever you do the bottom, do to the top. Now, for the bottom, it's the conjugate, so I can just get away with doing first and last. But the top, I have to do the whole FOIL, or memorize the binomial squared pattern. So 1 times 1, 1 times -I times 1, and then positive I squared. And then here, just first and last. And now I'm going to replace my I squareds and combine my like terms. So these two can be combined. And then I'm going to replace the I squareds with -1s. So I end up with 1 minus 2i. And then I replace the I squared with -1. And then the denominator here, it becomes 1 minus -1. The top, I notice I can 1 minus 1. Those reals are gone. So I'm left with -2i. And then the bottom is 1 minus -1, so it's positive 2. I can simplify, and I'm just left with -I. I'm going to go ahead and multiply by the conjugate, complex conjugate on number 14. So again, complex conjugate, same numbers, opposite sign. I need to FOIL the top. And again, if it confuses you and you forget the trick, FOIL both, the top and the bottom. But again, the conjugate, when you multiply it by it, the complex conjugate, just do first and last for the denominator. So the numerator, though, 2 times 4, first is 8. Outside gives you 4i. Inside gives you 12i. And last gives you 6i squared. Denominator, I'm just going to do first and last. And now I'm going to combine these two, and I'm replacing the I squareds with -1. So 8 plus 16i plus 6 times -1 over 16 minus 4 times -1. So now I get 8 plus 16i minus 6 over 16 plus 4. I need to combine my reals, so I can combine those and the denominator as well. So the numerator becomes 2 plus 16i over 20. And again, I can simplify here. I can divide them all by 2. So that'll become a 1, an 8, and a 10. So final answer here is 1 plus 8i over 10. If you want to pull it apart because you want to simplify that 8 over 10, you could do 1/10. And then when you put the 8 over 10, you could simplify that to 4/5 I. So either answer here is acceptable. Okay, so two more to do with rationalizing by multiplying by the conjugate. So my conjugate is 5 plus I, 5 plus I. I need to FOIL the top. The bottom I can get away with just doing first and last. So the top becomes 15 plus 3I plus 10I plus 2I squared, all over 25 minus I squared. So again, I can combine these guys, and then I'm going to replace the I squareds with -1. So 15, and when I combine those two in the middle, I get 13I. I'm replacing the I squared with -1. Replace this with a -1. And now I'm going to multiply 15 plus 13I minus 2 over 16. I now can combine these like terms, and I get 13 plus 13I over and this should be a 25I, so this should be a 26. And now I can simplify. I can divide everything by 13, and I'm left with 1 plus I over 2. Remember, when you simplify, that 1 is left behind. And then the last one here with the conjugate, again, my conjugate is 4 minus 3I. I gotta FOIL the top. The bottom I can just do first and last. Top becomes 16 minus 12I minus 12I plus 9I squared over 16 minus 9I squared. Again, combine those, replace the I squareds. So I'm now left with 16 minus 24I plus 9 times -1 over 16 minus 9 times -1. So I'll multiply 16 minus 24I minus 9 over 16 plus 9. I can add the top, add the bottom. 16 minus 9 gives me 7 minus 24I over 25. Nothing reduces here, so I stop there and leave that as my answer. All right, so now when you have negatives under the root, and we saw this at the beginning, so when we want to simplify a square root and when there's a negative number underneath the radical, we're going to pull out an I first, and then we'll simplify the positive root that's left behind. So again, if it helps you at the beginning to break it apart and think of the -3 as -1 times +3, and then this just simplifies to I, the square root of -1, and you can't break down the 3. For the -16, again, if you want to think of it as 16 times -1, square root of 16 is 4, square root of -1 is I. Down. So again, if you'd rather start out by doing 48 times -1, and then start breaking down the 48. So this would, I could do 16 times 3. And then if you want to keep bringing down the -1, the 16 comes out as a 4, the -1 as an I, and the 3 stays behind. So honestly, the breaking down of the radicals is still the same thing. The only difference is an I is going to come out of the radical. Same thing on the 500. If I break the 500 into 500 times -1, and then I'm going to break the 500 into 100 times 5. And then if I recognize that 100 is a perfect square, I can pull out the square root of 100, and that gives me 10. Pull out the -1, and it's going to give me an I, and then nothing to pair up or break down with the 5, so it stays behind. So 10I, radical 5. Generally, you'll see that the I is put in front. Remember, all three of these are being multiplied. So if you ever see something like this, it's the same thing. Just remember the 10, the I, and the square root of 5 are all being multiplied. Generally, you'll see it with the number, the I, and then the radical. And then 80, again, I can break it down into 80 times -1 first. Got to break down the 80. It's not a perfect square. I could do 16 times 5. Now, again, if you're not catching on that it's a perfect square, the biggest perfect square is 16. If you started with 8 times 10, you'd have to keep going. But this turns into, the 16 turns into 4. The square root of the -1 gives me the I. And then the root 5, I can't break it down. So 4I, radical 15. And this had a negative in front. Oh, I didn't catch that. Notice the negative outside. So it just stays outside in front of the 4I. Now, same idea here. If you think about it, I got a pair of 7s here. So what we could do is think of it as a pair of 7s, and then what comes out is a -7. The radical just disappears. So this answer is just -7 because I got a pair. Or if you want to break it down, -1, +7, -1, +7. And then here, if you square root that, you get I and I. And then notice you got the radical 7, a pair of 7s, I squared, and then the 7 comes out. And then I squared equals -1 times 7. And you get -7 doing it the long way. But just remember, whenever you make a pair of radicals, whatever was what was underneath it comes out. Now for the next one, you could either choose to multiply it, or what you can do is break it down. Now, don't be tempted to think that you need to, a negative times a negative is a positive, because then that's going to mess up your answer. So what we need to do is think of it like this. This is I radical 6 and I radical 10. Maybe just pull out the i's first. So these two i's become an I squared. And then I got to break down the 6 and the 10. So 2 and 3, 2 and 5. Notice you got a pair of 2's, so a 2 will come out, but nothing to pair with the 3 and the 5. So now I have I squared. I've got a pair of 2's, so a 2 comes out, and then the 3 and the 5 multiply back. This I squared now turns into a -1. So it's just going to be -2 square root 15. For the next one, let's pull out the i's. I radical 20, I radical 2. Here, I divided by I is just 1, and then 20 divided by the square root of 2 is just square root of 10. So if you can simplify what's under the radicals, do that. Next one. If you want to try to factor this, so this becomes an I could make this 24 radical 2 if you want to see it factored, or you can divide it either way. And then this simplifies. And then your final answer is just I radical 2. So if you would have preferred to just pull the I out of the 48 and then divide 48 by 24 and get radical 2 with the I out front. Either way. But just to show you could also factor it and then cancel the factors. Number 26. Again, this will become an I radical 5, I radical 15. I'm going to factor the 15. I got a pair of 5's. So a 5 will come out. Radical 3 stays behind. So final answer here, and this is an I squared. So then the I squared becomes negative 5, do blue, radical 3. The next one, this one I'll pull out the I, and then the 70, the I and the 7, the I's simplify, and then 70 divided by 7, square root of 10. Nothing to rationalize, it wasn't in any denominators. Same thing here, I could pull out the I could just divide it, and I get I radical 2, or you could factor it. It's a lot easier if it'll divide. You could have also broken the 40 and done 2 times square root 20 over 20, and then see that the 20s simplify, and you still get the same answer. Either way there. Let's try the next one. Again, I'm going to pull it out. Now, I could either choose to factor it or I could multiply it. Either way here. So let's go ahead and first I'll multiply it, I guess. So I get I radical 12, I radical 6, and then this is still just an 8. So what I could do here is multiply it, get I squared, 72 over 8. I squared becomes the negative sign, and then 72 divided by 8. So let's see, I squared, and then I get radical 9. I squared is negative 1, and the square root of 9 is 3. Now, you could have also, if you didn't want to multiply it, because maybe it wouldn't have been easy to divide, you could also have factored it. You could have made the square root of 12 become square root 4 times square root 3, and then the 6 becomes square root 2 square root 3, and then the 8 in the bottom is going to become square root 4 square root 2. Now, if you want to look for things to cancel before you multiply, you could say, well, 4 cancels that and that, because it's multiplied. It's not being added. And then your I squareds, or the I's become an I squared. So then you get I squared, and then you got a pair of 3's. So the 3 comes out. So negative 3 that way as well. And this you can't see. Oh my goodness. I squared times 3. I squared becomes negative 1. And then final answer, negative 3. Same answer I got when I multiplied them. So different ways to go about taking care of some of these. Pretty good there? All right. Let's try some more. Same thing. Okay, this time I've got and this should actually be a plus sign. Change this multiplication to a plus. Make an addition sign there on number 30. That's a typo. All right, so I'm going to fix the negative 128. So I can break it apart and do negative 8 plus I. And then I'm going to factor 128 into 64 times 2. I can now pull out the 64, and it's going to become an 8. So now I have negative 8 plus 8i radical 2 over 2. Now I can simplify. I can divide these all by 2. This becomes a 1, a 4, and a 4. And my final answer, did I do something wrong?
It's over 4.
It's over 4. Thank you. Why did I change that to a 2? Okay, this is 4. Thank you. There should be a 4. And these should be 2s. So now 8 divided by 4 is 2, both times, and then I get negative 2 plus or minus 2i radical 2. And that's your final answer there. Number 31, same thing, let's break down the 18. So negative 9 plus, I'll pull out the I for the negative sign, and then I can break this down into 9 times 2. So then the 9 I can square root, so it becomes negative 9 plus 3i radical 2 over 3, and now I can reduce. 3 goes into 3 once, 3 goes into 9 3 times, so final answer here, negative 3 plus I radical 2. And then same thing on 32, we're going to break down the 150, or the 50, the negative 50. So 5 plus, pull out the I, and this becomes a 25 times 2. Square root of 25 is 5, so it becomes a 5i radical 2 over 10. And now I can simplify. 1, 1, 2. So my final answer here is 1 plus I radical 2 over 2. Now, remember that I squared equals negative 1. We're going to use this fact to simplify these higher powers of I. So basically what I'm going to do is break it down. My 4 answers that whenever you have I raised to any power, there's always going to be 4 choices of an answer. It's either going to be 1, negative 1, I, or negative I. So if on a test you blank out and you get I to the 1000th power, put one of these as your answer. You got 25% chance of getting it right. Okay? There is a button on your calculator if you have the graphing calculator now that does this for you. But again, we're not using calculators yet. But if on a PSAT or an SAT, you get an I raised to some power and it's in the calculator portion, you can use your calculator. But I'm going to show you a super easy way to do this. So what we're going to do, and because this first one it's going to end up with 2 2s in it, I'm going to do a different example first. I'm going to do I to the 9th power first. So what I do is I take the power and I'm going to divide it by 2. It goes in here 4 times and I get a remainder of 1. Whenever my power is an odd number, I'm always going to have an extra I left over. So what I'm doing here is I'm going to break this 9 to the 9th power, and I'm going to break it apart. I'm going to take the fact that I know that I squared equals negative 1, and then I'm going to raise that to the number, the whole number of times that 2 went into that exponent and went in 4 times. But then I had 1 I left over, 1 remainder. Now what I'm going to do is I'm going to take I squared, replace it with negative 1. Whenever you have a negative 1 raised to an even exponent, the answer is always positive. If that exponent was odd, my answer is negative 1. So negative 1 raised to the 4th power, which is even, is positive 1, and then times I, and my answer to I to the 9th power is I. Now let's go ahead and try the number 33. And I just wanted to clarify where these numbers were going. Because when I divide 5 by 2, I get 2. So what I'm going to do here is start out with the I squared. 5 divided by 2, it goes in there 2 times. And it had 1 I left over. Remember, whenever that power starts out as odd, you're always going to have an extra I. And then now, negative 1, it's raised to an even power. So that becomes positive 1 times I, and my answer here is I. Number 32. I'm going to divide it by 2, and I get 16. Notice this was even. I didn't have an extra I left over. My I squared, which is -1, raised to an even power, and my answer is just +1. Next one. Again, I'm going to divide 33 by 2. Goes in there 16 times. So I squared raised to the 16th power, but I had a remainder of 1, so I got to put that I there. So I just did I squared raised to the 16th. This is -1. It's an even power, so it's 1 times I, and my answer is I. Number 36. Negative exponent. Remember, reciprocal turns it into a fraction. So we're going to take the whole thing, put it underneath a 1 first. Now we're going to turn it into the I squared. So 16 divided by 2 is 8. Remember, power to a power, you multiply. And now this turns into a -1 raised to the 8th power. 8's an even number. So -1 to an even power is +1, 1 over 1, and this answer equals 1. Let's try 2 more. Again, negative powers, we got to put them underneath a 1. I to the 101 power. Take 101, divide it by 2. It goes in here 51 times with 1 left over. So this is going to simplify into 1 over I squared raised to the 51st power with 1 I left over. I squared is -1. It's raised to an odd power. So that's going to be -1 times I. And then 1 over -I. And if you want to just pull it out, you could pull it out to the front either way. So oh wait, we got to rationalize, sorry. We need to rationalize this. And actually, I messed up on this multiplication. This should have been to the 50th power. Let me go back. This is to the 50th. It's an even exponent. So this is a +1 times I. Remember, you can't leave I in the bottom of the fraction. We got to rationalize. So let's multiply top and bottom by I. I over I squared. I squared equals -1. So my final answer is -I. And then the last one, 1 over I to the 102nd power. And again, I'm going to divide 102 by 2. This is the 51. So then I get I squared raised to the 51st power. It's even, so I don't have an extra I left over. So then I squared is -1 raised to the 51st power is just -1 because it's odd. And my answer here is -1. And that is it. And I know I skipped over those other ones. I will go back. So you have your homework on WebAssign. And tomorrow we will solve the quadratics. And again, this time our solutions can be imaginary.